This next section is, so let's continuing with our lettering. Let's continue with our lettering. The next section that we want to do in chapter 7 is to find the least common denominator, which we call the LCD. Okay, let's write down the steps so you won't forget. First thing you want to do is to factor each denominator separately. So remember, the whole story is about denominators. So factor each denominator separately, and then what you need to do is to get all the different factors. Okay, so get all the different factors, and take the highest exponent if possible. Okay, so if there's a repetition, take the highest exponent, and what happens is the LCD is the product of these factors. Okay, so let's try from our examples. Okay, so you understand what we're talking about. Okay, let's say this. Can you find the LCD of, say, 4x over x minus 2, 5x plus 1 over x squared minus 4x plus 4, and 3x cubed minus 2 over x squared minus plus 2x minus 8. So remember what the D stands for. D stands for denominator. Okay, so you don't care about the numerator, only the denominators. So do you notice for chapter 7, although we are dealing with rational expression from pretty much the beginning of chapter 7, but for different questions, different topics, okay, in chapter 7, you look at different things. Sometimes you look at both, sometimes you only look at the denominator. Okay, so now I'm focusing only at the bottoms, okay, like this. Okay, focus on this. So the trick is you're supposed to factor each denominator separately. So x minus 2, there's nothing you can do there. But for x squared minus 4x plus 4, the sum is a negative 4 and the product is a 4. So the two numbers are minus 2 and minus 2. So it's going to be x minus 2 and x minus 2. And you have to write it as x minus 2 squared. Okay, so you want it in exponent form. Okay, so let's do the last one. The sum is a positive 2 and the product is a negative 8. Which two numbers will do the trick? Positive 4, negative 2. Okay, so let's try that. X plus 4, x minus 2. Okay, so what I have now is, instead of the denominators that was given to me originally, I now have x minus 2 squared, and x plus 4, x minus 2. So according to the method to find the LCD, you're supposed to factor each denominator separately, which is what I did. Observe, I totally ignored the numerator. Okay, get all the different factors. Now, what are the different factors? So the different factors are the x minus 2's and the x plus 4. These are the different factors, and you're supposed to take the highest exponent if possible. So when you see x minus 2 by itself, it really means x minus 2 to the power 1. x minus 2 squared, that means his exponent is 2 versus the last one is again 1. So of these three exponents, you're supposed to pick the highest, so you will pick x minus 2 squared, okay? And you're supposed to multiply them, and there you have it. That's the LCD. So LCD is where you take all the different factors and the highest if you have a choice. Okay, so you don't combine them and say x minus 2 to the power 4. You just take the highest of the lot. So this actually is not too much different from what you have learned before. So if you recall, let's go back to familiar grounds. Let's deal with fractions. Okay, for example, if I say, can you find the LCD of 1/2, 5/8, and let's say I don't know 3/16, for example. Okay, so you notice you don't care about the 1 and the 5 and the 3. All you care about is the 2, 8, 16 because we're looking for LCD, right? And then you are thinking that 8 is really 2 times 2 times 2 3 times, so it's 2 cubed. This is 2 to the 1, and 16 is really 2, 2, 2, 2, so it's 2 to the power 4. So of these three, you will say the LCD is 16, because between 2, 1, 2, 3, and 2 to the 4th power, 2 to the 4th power is the highest of the lot. Okay, they're all 2's, but different exponents, so we take the highest one. So this is exactly what we're doing here. Okay, we're taking the highest exponent when we have a choice. So in this fractions, in this lot of fractions, 1/2, 5, 8, and 3/16, we will say the LCD is 16. We don't multiply all these numbers together. Okay, so this is the same concept that you have learned before, except that now we are dealing with algebra. Okay, let's try another example. Let's call this example 2. Can you find the LCD of, let's see, 1 over x squared plus 6x plus 8, x over x squared minus 16, and then let's try 4x over plus 3 over x cubed plus 8x squared plus 16x. Okay, let's try that. Okay, just focusing at the denominators, alright? Factor each one. So the first one is a trinomial. Sum is 6, product is 8. So I'm looking at 4 and 2. So x plus 4, x plus 2. Okay, let's look at x squared minus 16. That's a difference of squares, so it's x and x, 4 and 4, 1 plus, 1 minus. Alright, let's try this one. I need a GCF of x first, followed by x squared plus 8x plus 16. Okay, I have a sum of 8 and a product of 16. So the two numbers that will work is 4 and 4. So what is the answer for my last denominator? Let's extend the arrow. It's going to be x times of x plus 4, x plus 4. So we're going to call it x plus 4 squared. Okay, so what do we have here? We have, so what's the LCD? Okay, we need all the different factors. So there's x plus 4 here, and here, and here. But between them, I need the highest exponent. So it's going to be x plus 4 squared. What else do I have? I have x plus 2. There's no more x plus 2's, but I still take it anyway, because we need all the different ones. Okay, all the different factors. And what else? X minus 4. He's the only one who have it, but we'll take it anyways. And the last one, x right here, so we take that too. So LCD is really all the different factors, okay, and the highest exponent if you have a choice. Okay, so let's call this example 3, but example 3 is a bit different from example 1 and 2 because I'm going to get you to do a few things. First and foremost, I need you to find the LCD, and I need you to write or rewrite the rational expressions with the LCD as the new denominator. Okay, what does it mean by rewrite the rational expression with the LCD as the new denominator? Okay, so this is something again you've seen before. For example, the fraction is, let's say, two-thirds. Okay, let's say two-thirds. Say I no longer want you to use 3 as the denominator. I say, okay, can you use 45 as the denominator? Then that's when you have to think, okay, I have a 3 right now. That's right now what I have. How do I make 3 become a 45? So you have to think, how do I have to multiply? So the key is you need to multiply by something, and I need to use 15. Okay, 3 times 15 will give me 45. But at the same time, when I multiply the denominator by 15, I will have to multiply the numerator by 15 as well. Okay, so the original numerator was a 2, but now when I multiply by 15, it turns it into a 30. But the thing is, if you reduce this, you will still go back to your 2/3. So this is really what we used to call equivalent fractions, okay? As in like fractions that look different, but really their values are the same. And this is really what they are trying to get you to do. Okay, first you find the LCD, and they want you to rewrite every expression using the LCD as the new denominator. So equivalently, it's like asking you, can you convert 2/3 to a new fraction with 45 as the denominator? Something like that. Okay, now let's try the example, and let's say you are given, let's say you're given the fractions x over x cubed plus 27 and negative 2 over x squared plus 6x plus 9. Okay, let's try that. Okay, so let's look at the denominators. Right now I have x cubed plus 27, and that's supposed to be cubed, so it's x cubed plus 3 cubed. So little parentheses, big one. X plus 3 is in the little one. X squared, 3x, and 9. I need opposite signs for the first one, and the second one I need it to be a plus. Okay, and for x squared plus 6x plus 9, so x cubed plus 27 is x plus 3, x squared plus 3x plus 9. Sorry, there's a minus right there. X squared plus 6x plus 9, that's a trinomial. Sum is 6, product is 9, so the two numbers is 3 and 3. So that's going to be x plus 3 times x plus 3, which is x plus 3 squared. So let's call it x plus 3 squared. So what's the LCD in this case? Between x plus 3 and x plus 3 squared, I need to use x plus 3 squared, okay? And I need all the factors, so even the x squared minus 3x plus 9 has to be considered in the LCD. And that's it. I think we took care of everybody. That's become my LCD. Okay, so that's first part of the question. Can you find the LCD? Okay, so the LCD is done, finished. Okay, next part of the question is, can you rewrite each expression using the LCD as the new denominator? Now this is how you have to do it. The first fraction given to you is x over x cubed plus 27. His denominator is x over x plus 3, x squared minus 3x plus 9. Okay, but you want the new denominator to be x plus 3 squared and then x squared minus 3x plus 9. Now this is what you need to observe. When the numerator is x, his denominator is x plus 3, there, x plus 3, x squared minus 3x plus 9, like that, okay? So you need to compare this denominator with the new denominator. This is old denominator, okay? And that's new denominator. So between the old and the new, denominator. Between the old and the new, what is extra? So you notice that, hey, there's an extra x plus 3. So that tells you have to go over here to multiply by x plus 3. Remember the example on numbers, okay? This is exactly how you have to think. So you notice I'm missing an x plus 3 for the bottom. and that means I have to multiply an x plus 3 for the top. So what you do to the bottom, just do to the top as well. And so now the numerator, the new numerator, is no longer x, because I need to distribute this. And so what I have, the new numerator, is going to now be x squared plus 3x, and that's all they want. Okay, they want you to rewrite the old fraction with the LCD as the new denominator, but at the same time, when you change the denominator, you might have to change the numerator, okay, if they're different. Okay, let's try the other one. Which one is it? Negative 2 over x squared plus 6x plus 9. So his denominator is x plus 3 squared, but what I want is x plus 3 squared times x squared minus 3x plus 9. Again, compare the two. You notice, hey, you're missing an x squared minus 3x plus 9. Okay, so that means I have to multiply the top as well by x squared minus 3x plus 9. So when I distribute the negative 2 into the new numerator, it now reads negative 2x squared plus 6x and minus 18. Okay, let's call this example 4. Let's do it very similar to example 3. Same thing. Can you find the LCD? And rewrite each rational expression with the LCD as the new denominator. Okay, let's try that. Let's see. Let's do one that has 3 fractions. How's that? Okay, let's try this. 1 over x plus 1, x over x minus 2, x squared plus 2 over x squared minus x minus 2. Let's try that. Okay, so as far as denominators are concerned, there's not much I can do with x plus 1. There's not much I can do with x minus 2. Okay, so that's as factored as I can get. But the third one, the sum is a negative 1 and the product is a negative 2. So which two numbers will do the trick? I'm going to use negative 2 and positive 1. So what I have is x minus 2 and x plus 1. Okay, so let's determine the LCD. So x plus 1, I'm going down the line. I found another x plus 1 down there. They are really raised to the same exponent. Remember, you get to pick the higher of the two, and they're the same, so let's just call it x plus 1. Going down the list, I have x minus 2, and down the list there's another x minus 2. Again, these two are the same exponent. They're raised to exponent 1. So you get to pick. You're going to get to combine, okay? You don't combine them, you just pick the higher of the two. And since they are the same, 1 and 1, right? So we'll just pick 1. Okay, so you multiply these, and that's my LCD. There, done. Okay, now the next part of the question is, can you rewrite each fraction using the LCD as the new denominator? So let's go this way. So 1 over x plus 1, that was the original. Okay, and we want the new denominator to be the LCD, meaning we want it to be this. So your job is to figure out what's on the top. Okay, so go to the old denominator and compare with the new. So old and new, just keep comparing these two like that. You notice that you are missing a x minus 2. That's what you're missing. So I need to multiply an x minus 2 for the bottom, the denominator, to make it match, right? So if I do that to the denominator, then make sure you do that to the numerator as well. So 1 times x minus 2 is x minus 2. Now watch out, don't cancel the x minus 2, because if you do that, you go back to where you came from. Okay, and that's not what the question is asking you to do. They want you to rewrite each fraction using the LCD as the new denominator. So this is it. This is the answer we want, okay? Because they have the LCD as the denominator. Because if you try to simplify it, as in you cancel the x minus 2 like this, okay, you will notice that you're back to where you came from, okay? And you don't want that. Let's try the next one, x over x minus 2. So again, you want the x plus 1 and x minus 2 as the new denominator. So again, compare. Okay, that's always the case. Compare. So compare. Same here. Compare. You notice you're missing the x plus 1. Okay, so that means I have to do the x plus 1 for the top as well. This is multiplication. Okay, so I have to distribute. So you're no longer an x, you're now x squared plus x. Okay, and that's it. That's what we want. Okay, this is actually to prepare you for the next section where we are dealing with addition and subtraction of fractions. So what you're doing right now, it doesn't quite make sense to you because you'll be wondering why am I doing this? Why am I making the fraction so big? But that's really to prepare you for the next section. Okay, all right, last one, x squared plus 2 over x squared minus x minus 2. So this one, the denominator was factored as x minus 2 and x plus 1, right? And you want the denominator to be x minus 2 and x plus 1, exactly as you see it. So you notice that if you compare the two, compare again, there is nothing missing. So nothing missing as in you times 1. So if you times 1, it's as good as you don't do anything to it. So the numerator stays. Okay, so if you don't need to add anything to the denominator, then you don't need to add anything to the numerator. Alright, and that's that. Okay, can you try some as well? This is found on page 319. Okay, and let's get you to do these. Okay, this 23, 25, 31, and 47.